Welcome to Spring LIB.
This is the answer to Chapter 11, problem number 49 from the Smith Organic Chemistry textbook. And this problem says treatment of 2,2-dibromobutane with two equivalents of strong base affords 1-butyne and 2-butyne, as well as a small amount of 1,2-butadiene. Draw a mechanism showing how each compound is formed. Which alkyne should be the major product? Okay, the first thing that we need to do is going to be to draw the mechanisms for each of these. 1-butyne and 1,2-butadiene are going to proceed through a common intermediate, whereas 2-butyne is going to proceed through a different intermediate. Okay, the first thing that's going to happen here is going to be that, so we're using sodium amide as the strong base. That's what the problem says to use, and we're using two equivalents of it. And so the first equivalent, the part that actually acts as a base, is this NH2 minus. So the nitrogen has two lone pairs on it, as well as a negative charge. And so it is going to come and grab a proton. The electrons of this carbon-hydrogen bond are going to go here to form the new carbon-carbon bond. And this bromine will leave. It will take its electrons and go. And so that is going to get us to this alkene intermediate here. It's going to look like this. So we're going to have the carbon-carbon double bond here. Okay, yeah, so that's what I'll do. Okay, so we're going to have the carbon-carbon double bond here. And then this side will be CH2CH3. So there's the rest of the molecule. And then we're going to have bromine on this carbon. And this other carbon is going to have two hydrogens. Okay, and so I'm going to redraw this exact same thing right here, but I'm going to draw it a little bit differently. And you'll see why in a moment. So we could also draw this like this, where we have CH3, C, H, C, and we'll put a bromine here, carbon-carbon double bond here, and our two hydrogens here. So this is, again, this is the exact same molecule, just drawn two different ways. And so, as I said, the 1-butyne and 1,2-butadiene proceed through a common intermediate. And so this is obviously that common intermediate. And so what's going to happen next in both cases is the sodium amide, the second equivalent. So the NH2, again, two lone pairs and a negative charge, is going to grab another hydrogen. And these electrons can go here, and this other bromine can leave. And so if that happens, the product is 1-butyne. So the product here looks like this: CH3, CH2, C, CH. Okay, so there's our 1-butyne. But the sodium amide could also take a hydrogen from a different carbon. So if instead, and this is why I drew this one twice, but drew it a little differently each time. So if instead this proton is taken, Those electrons go there to form a new double bond there. And again, this bromine leaves. So this is exactly the same mechanism, just happening at a different location in the molecule. And so if this happens, the product here is CH3CH, double bond, carbon, double bond, CH2. And so that's our 1,2-butadiene. And that's the minor product. It's formed in a very small amount. And so the other thing that can happen, the third product, so again, this is going to be dependent on, well, not dependent on, but, oh man, I messed up. Okay, so I apologize. These should be bromines. I'm looking at them like why doesn't this make sense? So these should be bromines. Actually, let me move this whole thing up a little bit. Okay, so there we go. So these are bromines. It's always good to draw the right molecule. These are bromines. And so, again, sodium amides are base here. So the mechanism could start like this. So if this hydrogen is taken, double bond there, that bromine leaves. That gets us to this intermediate, which looks like this. So rather than a terminal alkene here, we've formed an internal alkene. And this could be E or Z. And in reality, I suppose it'll probably be a mixture of both. And so we have a hydrogen here. And then our second sodium amide, our second sodium amide comes along. Takes this proton. These electrons go here to form the triple bond, and this bromine leaves. And so our product after this, and I'm going to draw the long arrow just so that these three are sort of stacked one above each other. The product here is CH3C triple bond C CH3. So then between the two alkenes, we're asked which is going to be the major one, and it's going to be this one because it is more substituted. So a more substituted alkyne is more stable. And so we are comparing a terminal alkyne. So this one is terminal up top here to an interior. And so the interior is going to be more substituted, and that's going to mean it's more stable, and that's going to make it the major product here. Okay, and so this is the stepwise mechanism for each of these. It's just the sodium amide taking a proton to kick off a bromine and form a double bond. And depending on where that happens and then which proton is the second one taken, we get our three products here. And that's the answer to chapter 11, problem number 49.